Okay, hello all, this is Mr. Fong here. Now, we are going to talk about question 3 of your 2017 prelim paper. So basically, you're asked to use differentiation specifically to find the Maclaurin series of this expression in ascending powers of x up to and including x cubed. Alright, now, so basically, differentiation. The first thing that should pop up in your mind is actually implicit differentiation. Okay, and how do we go about this question? So now, first things first, you need to let y be equivalent to e to the power of 2x 1 plus x squared. And how do we employ implicit differentiation here? Okay, so let's rearrange this equation, okay, into something like this. Now, before we even differentiate this further implicitly, I just want to talk about the fact that a good number of students actually try to differentiate this thing, okay? Differentiate the one that I've circled in red, brute force. So how do they do it? They just do let dy dx equals to say they use a quotient rule here, and they get now what they do, so basically they e2x power 2 etc. Now, this is not a very efficient way to do this question. Okay, so please do not do that. Alright? Okay, let me try to erase this. Now, whilst I erase this, you must think about how to do this implicitly. Okay? Now, I am going to erase this blue-red line as well. Okay, please bear with me. Oops. There we are. Okay, now we can now continue. Alright, so differentiating this implicitly. Alright, now I'm gonna write this command here. So differentiate both sides implicitly with respect to x. Okay, so using chain rule on the left hand side, so you're going to keep y, you are going to differentiate this expression 1 plus x squared, get 2x, and then you are going to keep 1 plus x squared and then differentiate y, so you get dy dx. Of course, if you differentiate the left hand side, you must differentiate the right hand side as well. So you get 2e power 2x. Okay, now we need to differentiate this further. Okay, so we're going to differentiate both sides, blah 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 blah, with respect to x. You know what to write. Okay, so the first term y 2x, so differentiate this again. Okay, so y 2, and then dy dx 2x, this is just product rule all over, plus 1 plus x squared d2y dx squared plus x dy dx equals to 4e2x. Remember, if you differentiate the left hand side, you must also differentiate the right hand side. Okay, now the fact that the question asks you to find the Maclaurin series up to and including x cubed means that you need to have somehow have d3y dx cubed materializing out of something. Okay, and how do we do that? I mean, it's quite clear that from this expression, all right, the one that's underlined in red, you are to differentiate this expression one more time so as to have d3y dx3 materializing. Okay, now, and this is exactly what we will be doing. So we're going to differentiate the one underlying one more time implicitly with respect to x. Now at this point in time, I think I will not talk so much. Right, differentiate both sides. You know what to do. So again, this is product rule all over. In fact, let us not do that first, okay? Let us, now what have I done? Let us erase this, let's erase this, alright? Now let us tidy up the expression. Let's tidy up the expression in underlined in red, alright? So let us beautify this thing. So we have 2y plus 4x dy dx plus 1 plus x squared d2y dx squared equals to 4e2x. Now, this looks much nicer to deal with, and then we'll now differentiate we'll now differentiate the one that I've underlined in blue with respect to x. Okay, so differentiate both sides with respect to x. So we have 2 dy dx plus 4x d2y dx squared plus 4 dy dx plus 1 plus x squared d3y dx cube plus 2x d2y dx squared. Now that will be differentiating the left hand side of the expression underlined in red, and then similarly we'll also differentiate the right hand side of the expression, so it will be 8e2x. Okay, now tidy this up. We will have, or rather rearranging the equation, the expression that we have just obtained, we will have, alright, okay, let us start with the, we'll have, okay, 1 plus x squared d cube y dx cube plus 6x d2y dx squared plus 6 dy dx equals to 8e2x. Okay, so basically we have obtained 3 very long expressions, okay, by differentiating y equals to e2x 1 plus x squared implicitly. Okay, now so Okay, now let us talk about the second part. So find for x between -2 and 2 inclusive the set of values of x for which fx is within plus minus 0.5 of the values of hx. Now what exactly do they mean by this statement over here? Now the expectation is for you, or rather you're expected to be able to interpret this statement and write something like this. So since fx is within plus minus 0.5 of the value of hx, which means the difference between fx and hx is between or less than or equals to 0.5 inclusive. Okay, now if we are to write this expression out, so we have, now fx is something that you have found before, so if your expression for fx is incorrect, so we can expect this part, the answers for this part to be incorrect as well. Okay, now so we have x squared less than 0.5. Okay, if you want to take this a step further, you can actually decompose the modulus, so you have something like this. Okay, now how do you proceed further? You will actually proceed by solving this inequality using the GC. Now, from that little GC demonstration earlier, okay, how do we proceed to solve the inequality? So basically, now you are now going to have something like this. I mean, you can draw the diagram. In fact, I advocate the drawing of the sketch onto your script, okay, and then say something about x. Now you want to show proof that you've actually used the GC in your working. So firstly, you are going to write the inequality in 5SF first, or rather the more SF the better. 9, 5, 2, 3, 3, or etc. Okay, now this is the x coordinate of the other intersection point. Okay, and then from here you write the 3SF1, so negative 0.952, and voila. Okay, general comments for this second part. So a good many of you were unable to interpret the statement, okay, and come to the realization that you actually need to solve this inequality in green. Okay, now for some of you who have managed to come up with this inequality, somehow you falter in the GC part, okay, which I have no idea why, but so maybe you should try your hand at solving this again using the GC. Okay, and then let us talk about the first part very briefly again, just some very brief comments. Now, like I've said before, now some of you, in fact a good majority of you, okay, tried to differentiate this brute force, alright, dy dx, d2y dx squared. Now this approach is extremely tedious and prone to mistakes, because if you use quotient rule, or even say, let's for example you rewrite this equation into something like this and you decide to use product rule, okay, the result, or rather the outcome of getting these things, alright, is going to be very ugly.